Welcome to the next video in this mini-series. In this video, we're going to be talking about using LLMs to improve data quality in healthcare. My name is Vishwas Lele, and I'm going to be talking about a use case that pertains to inaccurate provider directories. So when patients need care, they search through a provider directory provided by their insurance provider. They want to find someone in the network or their healthcare plan that can provide them the medical service they need. These directories, and let me show you an example, these directories allow you to select a provider, and typically you go to your insurance website and you look for providers and you look for information such as the name, their address, their phone number, their affiliation, etc. Unfortunately, the provider directories are riddled with inaccuracies. In fact, a 2016 IDC health report finds that 20 to 30% of physicians are changing affiliations each year, and then about 5% doctors are changing their status, whether it is losing their license, retiring, passing away, or receiving some sort of a sanction. In summary, this provider directory is inaccurate, so you might go to your healthcare website, you might look up a doctor, you might approach that doctor, but only to find that that doctor is not in your network. And that can result in bills that you were not expecting. Fortunately, the United States Congress passed an act called the No Surprises Act. And the idea behind the No Surprises Act is that it seeks to protect consumers from receiving unexpected out-of-network bills. So with this act, insurance companies are required to update and verify provider directories at least every 90 days. In addition, they need to develop a protocol for removing providers that cannot be verified. So how can insurance companies maintain an accurate provider directory? Here are the 3 steps that these companies have to follow, and this can be an expensive process. They need to manage a master provider directory. They need to continuously monitor for changes and updates. And then based on those changes, they need to constantly update the master provider directory. As you can imagine, this can be an expensive operation to handle all of the updates from hundreds of providers. So let's now talk about how can LLMs help with this task, make it more cost-effective and less error-prone. It turns out that LLMs can help in 3 specific ways. First and foremost, rather than having to write every line of code to handle all of the data quality logic, with LLMs you can describe your intent and have LLMs execute that logic for you. LLMs are also very good at extracting entities, names, phone numbers, and addresses, which means that they can handle the changes to the underlying format and will require less maintenance. I'm about to show you how you can use LLMs to improve the quality of the provider data, but I should point out that I'm going to be focusing on just the prompts and the responses. Of course, when you use LLMs, you have to think about the entire application shown in the outer rectangle, and you have to think about orchestration and using tools like LangChain. I'm going to be focusing just on the prompt and prompt responses. The first thing we are going to do is going to go back to the insurance company website and just copy the information about one of the doctors. Of course, since I'm copying the information from the website, it is in unstructured format, and I need to go convert that into structured format. You may not need to do that if you have an API access to the underlying data. So let's just go ahead and run this prompt, and this will result in a JSON format as shown here on the screen. Now that we have the base information as part of our provider data, we are going to go out to a number of different data sources. We'll go to the Bing business directory, look for the same doctor. We are also going to go to WebMD and look for the same information. And in future, we might go to other data sources as well. So now we have the base record and we have information from 2 other providers. Let us go over back to LLMs and see if we can generate an updated version of this information. Let us go back and craft a prompt to help us update our system information based on the data that we got from external sources. So to be clear, we have three sources of data. We have the system record, we have the information from the web search, and we have the information from WebMD. Next, we are going to set up step-by-step instructions. Specifically, we are going to assign a confidence score. So we give a 60% confidence to web search. We give an 80% confidence to WebMD. And this is, of course, just an example of how you can set up your data quality rules. The next thing we are going to do is we are going to also provide it the context. So here's the system JSON snippet, the web search JSON snippet, and the WebMD JSON snippet. Let's continue on with our instructions. So here we tell the LLM to go field by field, compare the information across the three JSON snippets, and for each field, take our confidence score into account. So if there's an update in WebMD, that is going to override a change that may have happened in a web search. Now that we have the prompt defined, let's take a look at the output of the LLMs. So here it is showing us the discrepancy between the three JSON files. So right here, looks like the degree, there should be no change as expected. Look at the years of experience, no changes. Look at the address, looks like WebMD found a change, and since it was 80% confidence, it overrode the change that was available through web search and overrode the system record. Similarly for the phone number, similarly about whether the doctor is accepting new patients and the affiliation. So if we look at the updated system record, here you can see the address was changed based on the WebMD, the phone number was changed based on the WebMD, and then the hospital name was also updated to make it consistent with the WebMD information. Now that we have seen a data quality check example in action, let's take a step back and compare an LLM-based approach with an imperative traditional code-based approach. First and foremost, when you're writing a traditional code-based approach, you're responsible for defining every step of your logic. You also are required to do manual data parsing and validation, which means some of this logic can be more rigid, may not allow for dynamic changes. We know that we want to add new providers. These providers may change format. As a result, it might be more expensive to maintain this piece of code. In case of LLM-based approach, you're essentially defining your intent and letting LLMs generate the parsing logic. LLMs are good at entity extraction, names, addresses, phone numbers. As a result, if the underlying format changes, they're still able to extract that information, which makes it more flexible, which also makes it potentially less maintenance and less expensive. With this, we come to the end of this video. I thank you for watching this video. In upcoming episodes of this mini-series, we'll be talking about cost of LLMs as it pertains to data quality checks. We'll also talk about how you can effectively choose LLM models to optimize your cost. And finally, we'll talk about an important topic related to accuracy of these data quality checks. Thanks again, and see you in the next episode.